Is about miscellaneous exercise, chapter 5, and differentiation. The first sum in the miscellaneous exercise is y is equal to 3x square minus 9x plus 5 the whole to the power 9. You can consider this to be like a capital X. So then therefore dy by dx will be 9 into 3x square minus 9x plus 5 into differentiation chain rule is 6x minus 9. From this you can take 3 out common, it become 27. 3x square minus 9x plus 5 plus 2x minus 3, and that will be the answer for this. Let's go to second question. The second question is sine cube x plus cos to the power 6x. And if this is y, let's do dy by dx. It's like 3 sine square x into cos x plus 6 cos to the power 5x into cos x differentiation is minus sin x. The chain rule is applicable here. So if you assume this is like x cube with 3x square, so 3 sin square x, and x has to be differentiated again. So usually this is cos to the power 6x, like x to the power 6. So 6 cos to the power 5x into differentiation of cos x again will give you minus sin x. Okay. So let's go to third question. From this, whatever is common, you can write and you can check your book back answer. Next question is 5x the whole to the power 3 cos 2x. Okay, whenever you have x to the power x format and there's only single term, you can apply log on both sides. Log y is equal to log of 5x the whole to the power 3 cos 2x. And by the property, this can come forward. Log y is equal to 3 cos 2x into log of 5x. So then you, as soon as you see, you mark it as u and v. So log y differentiation is 1 by y into dy by dx is equal to 3 into u and v. Write cos 2x first as it is u into dv. Differentiation of log 5x is, you have to consider this to be a capital X. So that 1 by 5x. Log x differentiation is 1 by x, so 5x. Chain rule into 5. 5 and 5 get cancelled. Plus log of 5x into cos 2x differentiation is minus sine 2x into 2. Just write it in the forward, in the front, so that it's done. You don't need to solve it further. Dy by dx itself is 5y into y is nothing but from the question. You can substitute 5x the whole to the power 3 cos 2x into cos 2x by x minus 2 sine 2x into log of 5x. You can take x as LCM, do whatever. So that's about it. Let's leave it. You can check your book back answers, solve it further if required. Let's go to next question, which is the fourth question. A sine inverse of x into root x. X root x is x to the power 3 by 2. A sine inverse of x to the power 3 by 2 is like, you have to treat this as capital X. So sine inverse of x is 1 by root of 1 minus x square, which is x to the power 3 by 2 the whole square, where 2 and 2 get cancelled. Next, this blue color has to be differentiated, which is 3 by 2 into x to the power 3 by 2 minus 1 is 1 by 2, which is root x. There is a relationship. X to the power 3 by 2 when differentiated gives you 3 by 2 root x. Okay, just remember this relationship always. Okay, coming back to this can be written as 3 by 2 into root x by root of 1 minus x cube. So that's about it. So let's go to fifth question. The fifth question is cos inverse of x by 2 by root of 2x plus 7. Okay, that has to be done as u by v only. Okay, because it's not a prove that sum for you to take to the left side. I won't do that unless it's a prove that sum. I'll just do it as u by v. V into du minus u into dv by v square. Write what is in the denominator as it is. Or differentiate the numerator, where you have to consider this as capital X. So cos inverse of x is, put the minus here, by root of 1 minus x square by 4. And x by 2 when differentiated again will give you 1 by 2. Minus cos inverse of x by 2, a differentiation of denominator, which is like root x again. It's 1 by 2 into root of 2x plus 7. And differentiation of 2x is into 2. This is cos inverse of x by 2. You can't cancel the 2 and 2. This 2 and this 2 can be cancelled. By what is the denominator has to be squared. Root of 2x plus 7, the whole square will be 2x plus 7. So you can further solve it. As you can see from here, there's a minus root of 2x plus 7 by 2 into, when you take LCM here, the root of 4 minus x square by 2. 2 and 2 get cancelled. Minus what is in here is a cos inverse of x by 2 by root of 2x plus 7 by 2x plus 7. So when you take LCM for the numerator, you will get by root of 4 minus x square into root of 2x plus 7. So this will become minus 2x plus 7, and this will become minus root of 4 minus x square into cos inverse of x by 2. By you also have this denominator 2x plus 7. So therefore this root and that will get added as exponents and become 2x plus 7 whole to the power 3 by 2. So something like this is what I would do. So check your book back answer anyways and then proceed. So let's go to next sum. The next sum is success sum, which is cot inverse of root of 1 plus sin x plus root of 1 minus sin x by root of 1 plus sin x minus root of 1 minus sin x. So when you do like this will become the formula cos x by 2 plus sin x by 2 the whole square by root and square will get cancelled. And we solve the inverse trigonometry. And this 1 minus sin x is cos x by 2 minus sin x by 2 the whole square by root and square get cancelled. By again like this, so it will become cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2 will become plus sin x by 2. So cos and cos will get cancelled. Numerator sin and sin will get cancelled. Cot inverse of a 2 cos x by 2 by a 2 sin x by 2 will be cot inverse of cot x by 2, which will just be x by 2. Take this. This is what is y. You haven't even differentiated. You only solved the inverse trigonometry. So dy by dx will become 1 by 2. So let's go to next question. The next question is the seventh question, which is log x the whole to the power log x. Just consider it as y. It's like x to the power x format, applying log on both sides. Log y, because it's not log x to the power n for you to bring it forward. It's log x the whole to the power. So you need one more log. So log y is equal to log of log x the whole to the power log x. Now I can bring this forward. Log y is equal to log x into log of log x. So now this is done as u and this is done as v. 1 by y into dy by dx is equal to log x as it is, and this will be like a capital X, no? So log of log x is 1 by log x into 1 by x. So this and this get cancelled. Log of log x into log x differentiation is 1 by x. So therefore you get you can take a 1 by x totally out. You get 1 plus log of log x, and dy by dx itself is y into what is y? Log x the whole to the power log x, and this answer. Okay, this will be in square bracket. You can check your book back answers, of course. Let's go to next question. Eighth question is y is equal to cos of a cos x plus b sin x. So this is like cos of x. So dy by dx. So you're going to do dy by dx, which will become so cos of anything is minus sine of a cos x plus b sin x into a differentiation of the blue color is minus a sin x plus b cos x. So that's about it. Okay, let's go to next question. In answer, they probably would have brought this forward. So minus b cos x. No need a negativity. Let's not start with the negativity. Oh, this minus sign can be taken inside, right? Can be taken inside this. So it will become a sin x minus b cos x into sine of a cos x plus b sin x. You can write like this. Let's go to ninth question. The ninth question is sin x minus cos x the whole to the power sin x minus cos x, and this is like x to the power x. So log y is equal to sin x, yeah, sin x minus, okay, apply log on both sides, log of sin x minus cos x whole to the power sin x minus cos x. The கொண்டில் இருக்கிறது will come to the Monday. Log y is equal to sin x minus cos x into log of sin x minus cos x. So the moment you write this, you're going to do it as u by v. Okay, I lost the file. I'm sorry. Okay, I'll continue with the sum again. Okay, what was the question? Y is equal to sin x minus cos x the whole to the power sin x minus cos x is like x to the power x. So log y is equal to sin x minus cos x into log of sin x minus cos x. So u and this is v. 1 by y into dy by dx is equal to sin x minus cos x into log of sin x minus cos x is sin x 1 by sin x minus cos x, because it's like capital X, right? This itself is like capital X. So 1 by sin x minus cos x into cos x plus sin x. On differentiating what is in the blue color, this will get cancelled. Plus log of sin x minus cos x into differentiation of what is the first is cos x plus sin x. So what is common is cos x plus sin x. So you can take a cos x plus sin x totally out. You'll get 1 plus log of sin x minus cos x. You get it like this. So it's dy by dx is equal to y into what is y? Y is the question itself, which is sin x minus cos x the whole to the power sin x minus cos x. And this is the answer. Let's go to next question. 10th question. If y is equal to x to the power x plus x to the power a plus a to the power x plus a to the power a. This is x to the power x format. I can't apply log on both sides possibly because there are some more numbers with additions. When you have this, then you have to take it as a separate sum. Consider u is equal to x to the power x. Apply log on both sides. Log u is equal to log of x to the power x. So this one comes forward. Log u is equal to x log x. Going to do it as u and v. So 1 by u into du by dx is equal to முதல்ல இருக்கிறது அப்படியே இது ரெண்டாவது டிஃபரன்ஷியேட் பண்ணால் 1 by x ப்ளஸ் ரெண்டாவது இருக்கிறது as it is you write முதல்ல இருக்கிறது டிஃபரன்ஷியேட் பண்ணால் 1. So du by dx is 1 plus log x into this u will come here and u itself is x to the power x. So this is the answer for this. So this will become x to the power x into 1 plus log x, the differentiation of this. This is like x to the power number. So a into x to the power a minus 1. A to the power x differentiation, a to the power x log a to the base c. And a to the power a is completely a constant, so answer is 0. So this is the answer for it. Let's go to next question. 11th question. Y is equal to x to the power x square minus 3 plus x minus 3 the whole to the power x square. Okay, so this is the question. You cannot apply log on both sides because there's a plus here. So to take it as a separate sum, take this as a separate sum. So u is equal to x to the power x square minus 3. Applying log on both sides, log u is equal to log of x to the power x square minus 3. So log u is equal to x square minus 3 into log x. Okay, this is u and this is to be done as v. 1 by u into du by dx. X square minus 3 and a differentiation log x is 1 by x plus log x into differentiation of x square minus 3 is just a 2x. And du by dx therefore is u into, what is u? The question, which is x to the power x square minus 3. Into, if you take this LCM, you get x square minus 3 plus x. And this 2x can be written first, no? Because log x is separate. So you can write a 2x square into log x because having taken LCM, that x can be brought down here. And this can be taken as an exponent and will become x to the power x square minus 3 minus 1 will become minus 4. And this x square minus 3 plus 2x square into log x will still exist. You can check your answers in the book pack and make sure you're writing the right thing. And if there is any mistakes, you can highlight it in the comments or in the group so that others will know. So this is v. We've done only one part. So v is equal to x minus 3 the whole to the power x square. So applying log on both sides, log v is equal to log of x square x minus 3 into x square. So log v is equal to x square into log of x minus 3. So this will be 1 by v into dv by dx. This is done as u and v. முதல்ல இருக்கிறது அப்படியே இது, second இருக்கிறது differentiate, plus second as it is, first differentiate. And so dv by dx is v into, what is v? It's x minus 3 the whole to the power x square. The whole thing x square by, if you want to take x minus 3 as LCM, you can. So that the LCM x minus 3 will come out. And so it will be x square plus x minus 3 into log of x minus 3. And the 2x can be written forward in the front of this because the 2x is not a part of log, right? So you can do like this and leave it like this. It's your wish. And this can be taken as a power again, exponents, and you'll get x minus 3 the whole to the power x square minus 1 into the x square plus 2x into x minus 3, whatever, the whole thing can continue. Check your book back answer, make sure you're getting the right answers. I would have done a little more steps than given in the textbook, but that's okay. The 12th question is y is equal to 12 into 1 minus cos t, and x is equal to 10 into t minus sin t. It's parametric form. So dy by dt is 12 into 1 is 0, differentiation 1 minus cos t is plus sin t, and a dx by dt is 10 into 1 minus cos t, differentiation sin t is cos t. A dy by dt by a dx by dt will give you dy by dx, which is 12 sin t by 10 into 1 minus cos t. A 1 minus cos t is 2 sin square x by 2, so you write 2 sin square x by 2, 20 sin square t by 2. And the sin t on the top can be written as 2 sin t by 2 cos t by 2. So you can write it as 24 sin t by 2 cos t by 2. Sin t by 2, sin t by 2 get cancelled. This will become, if you cancel it with the 5 tables, no, 4 tables, 5 and 6. So you get a 6 by 5 cot t by 2 will be dy by dx. The same sum would be coming for d square y by dx square in the exam. Though that's not the textbook. That's not what is given. 6 by 5. A cot t by 2 differentiation, a cot x differentiation is minus cosecant square x, which is t by 2 here. And a differentiation of t by 2 is again 1 by 2. Into dt by dx is what the children will forget. And a dt by dx is a reciprocal of this. You need to substitute it here and then solve it. And that is something the children do forget. This is not what is asked in the book, but still I'm telling you, that's how they'll ask in the exam hall. And they'll also give at a point 20 is equal to pi by 4. You may have to substitute wherever t is pi by 4 and write the answer. So let's go to next question. And the 13th question is y is equal to sine inverse of x plus sine inverse of root of 1 minus x square. And dy by dx will be 1 by root of 1 minus x square plus this itself is sine inverse of x, including the root, correct? Which is 1 by root of 1 minus root of 1 minus x square, the whole square, where root and square get cancelled. Now differentiation of this blue color is root, it itself is root x, which is 1 by 2 into root of 1 minus x square into minus 2x, so 2 and 2 gets cancelled. This itself is x if you solve, and x and x will get cancelled. So you get 1 by root of 1 minus x square minus 1 by root of 1 minus x square. The answer will become 0. So let's go to 14th sum. If x into root of 1 plus y into root of 1 plus x is equal to 0, how do you solve dy by dx? This is called Kumar sum. X into root of 1 plus y is equal to minus y into root of 1 plus x. We're going to follow a special way of differentiating. X square into 1 plus y, first solve it. Y square into 1 plus x. X square plus x square y is equal to y square plus y square x. Consolidating, x square minus y square plus x square y minus y square x is equal to 0. X square minus y square plus xy into x minus y is equal to 0. This can be written as x plus y into x minus y. When you do that, what will be common is x minus y will become common. X plus xy is equal to 0. This cannot be 0 because this x and y will not cancel. So obviously x plus xy is what is 0. You take y common from here and write 1 plus x. So write what is y. Y is equal to minus x by 1 plus x. Therefore now you can do dy by dx. Take the minus out and do it as u by v. What is the denominator, write it as it is, and write what is the numerator is x minus மேல இருக்கிறது அப்படியே இது differentiation of denominator is 1 by 1 plus x the whole square, where this get cancelled, you get minus 1 by 1 plus x the whole square, which is exactly what you need to prove. The next question is the 15th question. If x minus a the whole square plus y minus b the whole square is equal to c square, prove that 1 plus dy by dx the whole square whole to the power 3 by 2 by d square y by dx square is independent of a and b. Let's call this as numerator, denominator. Let's solve them. Differentiating this is 2 into x minus a plus 2 into y minus b into dy by dx is equal to 0. Never forget the dy by dx, and 2 gets cancelled. And dy by dx itself is minus of x minus a by y minus b. You want to dy by dx the whole square and solving the numerator. So you get x minus a the whole square plus y minus b the whole square. So you substitute in 1 plus x minus a the whole square by y minus b the whole square, the whole to the power 3 by 2, just to solve the numerator. Take LCM, you get y minus b the whole square plus x minus a the whole square by y minus b the whole square whole to the power 3 by 2, where this is nothing but the question itself, which is c square by y minus b the whole square whole to the power 3 by 2. 2 and 2 gets cancelled, it will become c cube by y minus b the whole cube. This is numerator's differentiation answer. Now you have to solve the denominator. Denominator is d square y by dx square. To get that, you need to know what is dy by dx. You should remember it's minus of x minus a by y minus b. You're going to double differentiate it. Okay, which means take the negative sign out. What is in the bottom? Write it as it is. Differentiation numerator is 1. Minus what is the numerator? Write it as it is. Differentiation denominator is dy by dx by y minus b the whole square. Substituting this here, become minus of y minus b plus x minus a the whole square by y minus b by a y minus b the whole square. So now LCM on the top will get you y minus b the whole square plus x minus a the whole square by a y minus b the whole cube. So this will become minus c square by y minus b the whole cube, and this is the denominator's answer. What was the numerator's answer? C cube by y minus b the whole cube. Denominator's answer is minus c square by y minus b the whole cube. So answer is minus C. Thus the answer is independent of A and B. So let's go to next question. The next question is the 16th question. 16th question is if cos y is equal to x into cos of A plus y, prove that dy by dx is equal to cos square A plus y by sin A. The moment I see cos square, I know I have to bring this down and do it in a specialized way. Cos y by cos of a plus y, so that I can do dx by dy because it's x. So that I can answer reciprocal my final answer to get dy by dx. கீழே இருக்கிறத அப்படியே எழுது. மேலே இருக்க டிஃபரன்ஷியேட்னா மைனஸ் சைன் y and dy by dy only, so it's 1. Minus, what is the numerator? Write it as it is. Differentiate denominator, cos of a plus y is minus sine of a plus y dy by dy only by a cos square a plus y. Done it as u by v now. V into du minus u into dv by b square. Now this is like sin a cos b minus cos a sin b, which is sin of a minus b by a cos square a plus y. So y and y get cancelled. This is my dx by dy. So reciprocal, you get cos square a plus y by sin a, and which is what exactly you need to prove. So let's go to 17th question. If x is equal to a into cos t plus t sin t, and if y is equal to a into sin t minus t cos t, find what is d square y by dx square. Let's parametric form, as you can see. Let's differentiate this. Minus sin t plus, this is to be done as u and v. Children, do forget that only. U into cos t plus sin t into 1. When you open this bracket, the sin t get cancelled. Thus you get at cos t. Do this differentiation dy by dt. A into cos t minus, this is to be done as u and v, t into minus sin t plus cos t into 1. So cos t will get cancelled when you open the bracket, because the whole bracket. So it will be get at sin t here, and dy by dt by a dx by dt will give you dy by dx, which will be at sin t by at cos t, which will be tan t. Now you want a d square y by dx square. That's not, yeah, that's what they're asking. A tan t differentiation is secant square t into dt by dx is what you'll forget. Again, I'm telling you. So secant square t by reciprocal of dx by dt is at cos t, so secant cube t. So at that point, if they ask you t is equal to pi by 4, you can always substitute secant pi by 4. Cos pi by 4, cos 45 is 1 by root 2. So it will be 2 root 2 by 80. Or t is also again pi by 4, so you'll get a pi by 4. Whatever that answer is, you can just substitute as it is. Okay, so let's go to next question. Next question in the textbook is 18th question. Sorry. So next question is 18th question. If f of x is equal to mod of x the whole cube, you have to redefine this function. X is less than 0, f of x will become minus x cube. X is greater than 0, f of x will become plus x cube. So f dash of x is equal to minus 3x square. F double dash of x here is minus 6x. Here f dash of x is equal to 3x square. F double dash of x is equal to 6x. Thus, f double dash of x is minus 6x when x is less than 0, and f double dash of x is equal to plus 6x when x is greater than or equal to 0. And this is our answer. Let's go to next sum, which is 19th sum is omitted, mathematical induction sum. 20th question is sin a plus b. You know, is sin a cos b plus cos a sin b. Using differentiation, you have to find the formula for cos a plus b. So differentiating, you get cos a plus b into dA by dx plus dB by dx is equal to, this has to be done as u and v, this has to be done as u and v, sin a into minus sin b into dB by dx plus cos b into cos a into dA by dx plus this has to be done as u and v again, which is cos a into cos b into dB by dx plus sin b into differentiation of cos a is minus sin a into dA by dx. So consolidate dA by dx, consolidate dB by dx. If you consolidate dA by dx, you will get cos a cos b minus sin a sin b. Sorry about my bad handwriting. And then you will consolidate dB by dx. You'll again get a cos a cos b minus sin a sin b. Now you can take out cos a cos b minus sin a sin b common. Cos a cos b minus sin a sin b will be common. You'll get a dA by dx plus dB by dx, which will get cancelled with the left hand side, and thus you got a formula for cos a plus b. So let's go to next question. The next question is the 21st question, where does there exist a function which is continuous everywhere but not differentiable at 2 points? A modulus function which is like this. Supposing this is it can even be like this. Now let me write it in the positive quadrant. So this is 2 and this is 3. This function is mod of x minus 2 and this function is mod of x minus 3, and addition of these two functions will lead you into this is a continuous function. It's continuous everywhere. If you see, you can draw this without taking your hand. Yes, continuous everywhere, but is not differentiable at 2 and is not differentiable at 3 because the slope is 0. That slope does not exist at 2 and 3. So this is a good example of something which is not differentiable at exactly 2 points, but it's continuous everywhere. Let's go to next sum, which is the 22nd sum. And if y is equal to f of x, g of x, h of x with an L, M, N and with a, B and C, prove that they're asking dy by dx. Okay, let's find the determinants of this first. Freeze this. F of x into mc minus nb, top to bottom minus bottom top, minus gx into lc minus an plus h of x into lb minus am. This is what you get. And you just solve the determinants, then that's what is y is value, the value of y. Now you have to do dy by dx. This is a constant mc minus nb, become f dash of x minus lc minus an into g dash of x plus lb minus am into h dash of x. Differentiation, that's all. So therefore you can write this converted as, just copy what is dy by dx, f dash of x, g dash of x, h dash of x, just copy it, l, m, n, a, b, c, because when you solve this you'll get this. So therefore it's proved. So last sum, 23rd question, y is equal to e to the power a cos inverse of x. So do dy by dx is equal to e to the power a cos inverse of x minus a by root of 1 minus x square. Since it's a prove that sum, you have to take it to the left hand side. Okay, and write minus a e to the power a cos inverse of x. Differentiate it as u and v. Root of 1 minus x square into d square y by dx square plus dy by dx into 1 by 2 into root of 1 minus x square into minus 2x is equal to, a differentiation of this will be plus, because you already differentiated here, minus a is already there, so it will become plus a square e to the power a cos inverse of x by root of 1 minus x square. Now cross multiply, you get 1 minus x square d square y by dx square minus x into dy by dx, because root of 1 minus x square would get cancelled. Minus a square y is equal to 0, because this itself is y. And or you can take LCM and cancel the denominators. Either way, you get the same answer. I'm sure you understood.